Hello, this is Dr. Hanaa Assil, and this is another video about AS Edexcel chemistry. And today we're discussing one of the recent papers in Unit 1. So this is the one that was in June 2021, very recent. And we will discuss the answers to the questions while revising these points in the syllabus. So this is section A. Again, I'm reminding you, section A is all multiple choice and you should put an X in the cross. Okay, the first question says the numbers of subatomic particles present in 4 species are given in the table. Which of these species are isotopes? Remember again, an isotope or isotopes are atoms of the same element having the same number of protons. So we're looking at two of these that have the same number of protons but different number of neutrons. So looking at this, the two that have same number of protons but different number of neutrons are Y and Z. Okay, the next question says iodine exists as an isotope with mass number 127. Chlorine exists as two isotopes with mass number 35 and 37. So how many molecular ion peaks are there in the mass spectrum of ICl3? So he's telling me that iodine has only one isotope, but chlorine has two isotopes. So the chlorines in the ICl3 can either be 35 or 37. So how many different possibilities can we have? You should realize that the iodines are the same, but the three chlorines, they can either be all three of them are 35, or one of them is 37, or two of them are 37, or all three of them are 37. So these are the different possibilities I can have, and that means that I have 4 molecular ion peaks that are possible in the mass spectrum of this molecule. Okay, this one again is about mass spectrum, and he's saying this is an element that has only 2 peaks. What is the approximate relative atomic mass of the element? Remember that when we have elements, the peaks are due to the different isotopes and showing their different abundances. So this mass spectrum shows me that I have 2 isotopes. One of them has a mass of 191 and the abundance is about 25%, while the other one is 193 and the abundance is about 75%. You know how to calculate the overall relative atomic mass. It is the mass number times its abundance plus the mass number of the other one times its abundance over 100. So this gives an average of 192.5, and that means that's the relative atomic mass. Okay, next question. He's asking which equation represents the second ionization energy of magnesium. Again, remember, second ionization energy means I am starting with the species with one positive charge. It is going to lose an electron and become 2 positive charges. And all of these have to be in the gaseous state. So which of these is correct? That's this one. Okay, starting with the one positive to give 2 positives and losing 1 electron, and the species are in the gaseous state. Okay, this one is about ionization energy. Okay, so this is giving the ionization energies for an element, the successive ionization energies, first, second, third, fourth, and so on for an element. Now, in this element, he's saying, first of all, how many quantum shells? How do I know how many quantum shells? Well, looking at the graph, I can see at the beginning, there's a gradual rise, and then there is a sharp jump from 5 to 6. And then gradual rise, and then another sharp jump from 13 to 14. And that means that I have 2 sharp jumps. And remember that each sharp jump in the ionization energy indicates a change from one energy level to the inner one. This means that we have 3 energy levels. Now, what is the number of electrons in the outer shell? Well, how do I know that? From the first, second, third, fourth, fifth, all of them are very near to each other, and the first huge jump is after the fifth ionization energy. That means that it had 5 electrons in its outer shell. So the answer is okay. So the answer is B. The next question says which ion has the electronic configuration this in its ground state. So that means we're looking for this one of these ions with a total of how many electrons? 2 plus 2 is 4 plus 6 is 10 plus 8, that's 18. I need one of these to be 18 electrons. So let's take a look. Aluminium has originally 13 electrons. If I say 3 plus, that means it has 10. That's not the one we want. Now, chlorine originally has 17. When it has 1 negative, that means it has an extra electron. That is 18 electrons. Let's take a look at the others. Nitrogen originally had 7. If you add 3 electrons, that's 10. Sodium originally had 11. If you remove 1, it's 10. So my answer is B. What is the relative formula mass of this? Again, to remind you, relative formula mass is just the addition of all the atomic masses of each atom. So what do we have here? We have 2 sodiums, each of them 23, so that's 23 times 2, plus 1 carbon, that's 12, plus 3 oxygens, that's 16 times 3, plus the water. You need to add that part of the water. So I have 2 times 10, that's I have 20 hydrogens, and each one has a mass of 1. And I have how many oxygens? I have 10 oxygens, so that's 16 times 10. The total is 286. And the next question says, which of these isoelectronic ions has the largest radius? Remember, the word isoelectronic means they all have the same number of electrons. So if you're looking at sodium, and sodium originally has 11 protons in its nucleus, it has 11 electrons, and that means the Na plus will have 10 electrons. Now, which of these has the largest radius? They all have 10 electrons, but the difference between them is the number of protons in the nucleus that are attracting these 10 electrons. So the bigger the number of protons in the nucleus, the smaller the radius, because then you'll have stronger attraction forces between the nucleus and the electrons. So I am looking for which one has the largest radius. That means I'm looking for which one has less protons in the nucleus attracting these 10 electrons. So the one with the smaller number of protons is the oxygen. It has 8 positives in the nucleus attracting the 10 electrons, while fluorine has 9, sodium has 11, and magnesium has 12. So these are smaller radius. Okay, the next one says which ion is the most polarizable. Now remember that to be polarizable, first of all, we're going to choose one of the negatives, not one of the positives. And we're going to choose the one that is bigger in size. So the bigger the negative ion, the more polarizable it is. So in this case, if we're looking at where is magnesium and calcium and chlorine and iodine, the one with the biggest atom originally is iodine. So if it forms I minus, this would be the most polarized. Which substance has a giant lattice of atoms? First of all, giant, you should know which of these are giant. Well, diamond is giant, and sodium chloride also is giant, but he's looking for something that is a giant lattice of atoms. Remember, sodium chloride is giant, but it is not made up of atoms, it is made of ions, positive and negative ions. So the one that is giant atoms, that is diamond. Which compound has bonds that are the most polar? Well, let's look. We said the most polar means something that has more electronegative element. So what do we have here? We have water and H2S and NH3 and pH3, and you should know that comparing oxygen and sulfur and nitrogen and phosphorus, the one that is more electronegative is the oxygen, so its bonds will be the most polar. Which molecule is planar? Well, now here we need to draw them. CF4 is something that would look like this, so that is actually tetrahedral. C2H4 is a planar molecule. PF5 would look like this, so this is actually a trigonal bipyramid. And this one is FS6, so this is actually an octahedral structure. So the one that is planar is the C2F4. The next question says, when C20H42 is cracked, each molecule produces one molecule of ethene, one molecule of butane, and two molecules of a hydrocarbon that he calls E. And he's saying, what is the molecular formula of E? Well, I would write something like this. Now, C20H42, he's cracking it to give what? Ethene, ethene is C2H4. One molecule of butane, that's C4H10. And two molecules, don't forget that there are two, of something. So you want all the number of carbons after the arrow to be equal to the number of carbons before the arrow. And all the number of hydrogens after the arrow should be the same as number of hydrogens before the arrow. So I want a total of 20 carbons. If I have 2 plus 4, that is 6. I want how many carbons then? I want 2 times 7, which is 14, to make it a total of 20. Now, I had a total of H42. So 4 plus 10 is 14. If I have 2 times 14, that's 28. 28 plus 14 will give 42. So my molecule is C7H14. Do we understand that? Okay. What is the systematic name of this compound? Well, let's see. The first thing we do to get a systematic name is determine the longest chain. Where do we have the longest chain? Well, let's see. 1, 2, 3, 4, 5, 6. So this is a hex. So actually my compound should be C. This is hex 1-ene. And then I have methyl groups, and the methyl groups are on carbon number 4 and carbon number 5. So actually the systematic name of this compound is 4,5-dimethyl hex 1-ene. That is correct. Okay, here we have cyclohexene may be prepared by the dehydration of cyclohexanol. We know that dehydration means removal of water. What mass of cyclohexene can be made from 12.5 grams of cyclohexanol if the yield is 51.2%? Okay, usually he gives you the equation. He gives me the information about cyclohexanol, but then he's asking me about cyclohexene. So the first thing I should do is get the number of moles of the cyclohexanol. We know that number of moles is mass over molecular mass. He already calculated the molecular mass for me, so I don't need to waste time and sit down and try and calculate it. So number of moles of cyclohexanol is mass over molecular mass, so that is 0.125 mole. Then I look at the equation and try to compare from the equation what is the relationship between their number of moles. Well, obviously from the equation, the number of moles of cyclohexanol is the same as that of cyclohexene, so the number of moles of cyclohexene will be the same. That means that I need to calculate what would be the mass of cyclohexene that he should get originally. The mass is number of moles times mR. Well, number of moles times the mR that he already gives me. That means he's supposed to get 10.25 grams of cyclohexene. But then he said the yield is only 51.2%. Yeah? That means he will get only 51.2% of what he should get. And that means he will get 51.2% of the 10.25. So 10.25 times 51.2 over 100, that means he will get actually only 5.25 grams. Okay, the next question says, which of these gases occupies 6 decimeter cubed at room temperature and pressure? First of all, if I want to find out gases that occupy the same volume, that means they should have the same number of moles. And that means the first step should be to get the number of moles of the 6 decimeter cubed. Now, I can use the equation that says number of moles is volume over 24 because he tells me it's at room temperature and pressure, so we can use this equation. So the number of moles is 0.25 mole. Now, if he says which of these have the same volume, that means he's saying which of these has 0.25 mole. So let's calculate the number of moles of each one. The first one says 2 grams of helium. Number of moles is mass over molecular mass, so 2 over the molecular mass of helium, which is 4. So that has 0.5 mole. That's not my answer. The other one says 4 grams of oxygen. Remember that oxygen here is O2. So actually, molecular mass of oxygen is 16 times 2, which is 32. So this number of moles is 0.125. No, that's not my answer. Now, the other one says 11 grams of carbon dioxide. Well, 11 over the MR of carbon dioxide, CO2, is 0.25, and that means that is my answer. The 14 grams of nitrogen also does not give me the correct answer. So we're looking for which one has 0.25 mole. Okay, the next question is about empirical formula. So he's saying an oxide of lead contains 90.7% by mass of lead. Of course, if this is an oxide, that means it has lead and oxygen. 90.7, the rest of the 100 is 9.3, so that's the first thing I'm supposed to get. Now remember, again, remind you to the fact that in order to get empirical formula, the first thing we do is divide by the atomic mass of each one. Now, the numbers that come out, I look at which one is the smaller one, I divide by the smallest. So that comes out to be 1 to 1.33. Remember, if it is not 1.0 or 1.9, we do not round it up. 1.33 means I need to think of something that I can multiply it by in order to get a whole number. So if you try 2, it doesn't work. Multiply by 3, it will work, and that means your actual ratio is 3 to 4. Please, when the ratio comes out to be 1.3, do not round it up to 1. Don't say it's 1 to 1. Multiply by a number that makes this, whether it's 1.3 or 1.4 or 1.5 or 1.6 or 1.7, you need to multiply by a number that gives you a whole number. So actually the molecular formula here is Pb3O4. Now the next question says propane burns completely in oxygen as shown, and he gives me the equation, and he says 100 centimeter cubed of propane was mixed with 600 centimeter cubed of oxygen, and the mixture was ignited. What is the total volume of gas at the end of the reaction? So if I look at the equation, remember that we can relate directly the volumes of gases. So if I say I have 100 centimeter cubed of propane, now how much do I need of oxygen? Well, the equation says 1 to 5, that means 100 will need 500. How much CO2 will be given up? Well, the equation says 1 of C3H8 gives 3 of CO2. That means 100 will give me 300. So that means that when I put in 100 centimeter cubed of propane, I will use 500 of oxygen and I will produce 300 of CO2. But then how much of oxygen did he put in? He put in 600. That means actually I have 100 centimeter cubed of oxygen extra. So the total volume of gas at the end of the reaction, of course, the 100 centimeter cubed of propane has been used up. So I don't have propane anymore. But I do have the 100 centimeter cubed of oxygen that is left, plus the 300 centimeter cubed of CO2 that was formed. So I actually have a total volume of 400 centimeter cubed of gas. Okay, which aqueous solution contains the greatest number of ions. Remember, to get the number of ions, we said we use Avogadro's number times the number of ions that we have times the number of moles, so on. So we said if I have 200 centimeter cubed of 1.5 mole per decimeter cube, I need to get the number of moles first. So the number of moles would be concentration times volume. So 1.5 times, remember the volume has to be in decimeter cube, so it's 1.5 times 0.2. But that number gives you the number of moles. Now, each MgCl2 will give you how many ions? It will give 1 magnesium ion and 2 chloride ions. That means I have a total of 3 ions. That means this number of moles, 1.5 times 0.2, I have to multiply by 3 because I have 3 ions, times Avogadro's number, so that's 6.02 times 10 to the 23. So this comes out to be 5.4 times 10 to the 23. Again, let's try B. What is the number of ions in B? Well, in B, he has concentration is 0.8 and 400 centimeter cube, that means 0.4 times magnesium sulfate will give how many ions? 1 magnesium ion, 1 sulfate ion. So I have a total of 2 ions. So the number of moles times 2 times Avogadro's number. The next one gives the number of moles, which is 1 times 0.5, concentration times volume. Sodium chloride will give how many ions? 1 sodium, 1 chloride. That means I have a total of 2 ions times Avogadro's number. The last one, concentration times volume, 0.25 times 1 times sodium sulfate will give how many ions? It will give 2 sodium and 1 sulfate. So I have a total of 3 ions times Avogadro's number. Now, which of these is the highest number? Well, the highest, they're all times 10 to the 23, so you just compare the others, 5.4, 3.9, 6.02, 4.5. So the one that gave me 6.02 times 10 to the 23, this gives the greatest number of ions. Okay, this question says a sample of seawater with a mass of 1 kilogram contains 6 times 10 to the minus 9 grams of gold. How many atoms of gold to one significant figure are there in 1 gram of this seawater? Okay, so the first thing he says, 1 kilogram has 6 times 10 to minus 8. Now 1 kilogram, that's 1,000 grams. Have 6 times 10 to the minus 8 grams of gold. So the 1 gram of water will have how many? You divide 6 times 10 to the minus 9 over 1,000. So that comes out to be 6 times 10 to the minus 12 grams of gold. But he wants how many atoms? That means I need to get number of moles. Number of moles is mass over molecular mass. Molecular mass of Au is 197. And that gives me the number of moles. Okay. But then he wants the number of atoms. And remember that that means I have to multiply by Avogadro's number. So I end up with 1.8 times 10 to the 10. But then he wants to only one significant figure. So I have to round up the 1.8. So the answer is actually 2 times 10 to the power of 10. Are we following? Okay, I hope it's not too difficult. Here he's saying heptane C7H16 is an alkane found in crude oil. Heptane can undergo incomplete combustion. Give a reason why incomplete combustion sometimes occurs. Remember that we have incomplete combustion if there is limited supply of oxygen or lack of oxygen or less oxygen, whatever gives you the same meaning. Then he says, write the equation for incomplete combustion of heptane that forms carbon monoxide and water as the only products. So he already gives me the formula of heptane up there, C7H16. Even if he does not give me, you should realize that hept means 7. And the general formula for an alkane is CnH2n plus 2. That means the H's will be 2 times 7, 14, plus 2 is 16. So this is C7H16 plus, of course, combustion means reaction with oxygen. And he says this gives me carbon monoxide plus water. and then you balance. So we have 7 carbons before the arrow. I need 7 carbons after the arrow. We have 16 hydrogens before the arrow. That means I need 2 times 8 of hydrogen. Now that means that after the arrow I have a total of how many oxygen? 7 plus 8 is 15. So before the arrow I need 2 times 7.5. Of course, you can leave it like this, or you can multiply through by 2. So your answer can be 2 of C7H16 plus 15 of O2 plus 14 of CO plus 16 of H2O if you want. Now, the next question says, heptane is reformed into branched chain and cyclic hydrocarbons that are used in petrol. Draw the skeletal formula. Do you remember how to draw skeletal formula? Of a branched chain alkane and a cycloalkane, each containing 7 carbon atoms. Now, there are many choices that you can choose from. You want a total of 7 carbon atoms, but you want it to be branched, so the 7 cannot be all after each other. So this is an example of one of the possibilities that you could draw. 7 carbons means I can put 6 carbons all after each other, and then one of them is a branch, or you can put them actually in many different possibilities. Now, the cycloalkane, I can put 6 carbons as a ring, and then one as a branch, or all 7 in a ring, or there are actually many, many possibilities. Write the equation for the reforming of heptane into a cycloalkane, and he's saying use molecular formula. So heptane is C7H16. Now you should realize that cycloalkane, the cycloalkane has less hydrogen. So in order to make something cyclic, you remove an H2 from it. So actually the cycloalkane with the 7 carbons will be C7H14 plus H2. Give a reason for adding cycloalkanes to petrol. If he says any of these kinds of questions where he says, why am I using cycloalkanes, why am I adding something to the petrol, it is most probably for more efficient burning or more efficient combustion. Okay, heptane reacts with chlorine in presence of ultraviolet radiation. Remember, an alkane with a halogen. What type and mechanism of this reaction? The alkane with halogens are free radical substitution reactions. Remember that in this syllabus for Unit 1, we only have 2 mechanisms you're supposed to learn. One of them is the free radical substitution reaction, in which you're reacting an alkane with a halogen like chlorine. So here he's saying give the mechanism for the reaction, and he wants to produce the chloroheptane and C14H30. That means 2 C7s together and HCl. So remember, first of all, the free radical substitution mechanism is made up of 3 steps. The first step is the initiation step that requires the ultraviolet radiation, because the ultraviolet radiation breaks up the bond between the 2 chlorine atoms into 2 chlorine radicals. So the initiation step is where you're changing the Cl2 to 2 chlorine radicals. Now, the propagation step is where I'm removing one of the hydrogens from the C7, so it becomes C7H15 radical, and that hydrogen binds with the chlorine radical to form HCl, so this is one of my required products. And the C7H15 radical will then help to break up the next Cl-Cl bond. So this forms the C7H15Cl plus another chlorine radical that will go back again and do the first step of the propagation and go on in a cycle until we reach a termination step. And you should know that the termination step requires 2 radicals to join together. Now he wants the one that will give C14, so I have 2 radicals of the C7 combining together to form the C14H30. Okay, this question is about the elements in period 3 and some of their compounds, and he has atomic number and atomic radius. And the first question says, plot a graph of the atomic radius against atomic number. remember again, how do we draw graphs? The first thing we do is we label the axes and we write the distribution of numbers. So the atomic, again, which one goes, if you don't remember, which one goes on the x-axis? It's usually the upper one in the table, or the one on the left if the table is vertical. So atomic number will go down, and the y-axis will be atomic radius in nanometers. Now we're going to divide it so that we use as much of the graph paper as possible. So this is the best distribution of the numbers that we had in the table. Again, the first thing we do is plot using a small x or a dot with a small circle. Then we join it with a curve, and then he says use the graph to estimate the radius of silicon. Now silicon is the one with atomic number 14. So I go up to the graph from 14, I find that this is about 0.112 nanometers. Okay, the next question says, suggest an explanation for the decrease in atomic radius as atomic number increases across a period. Remember, as we go from left to right in a period, the atomic radius decreases. Why does it decrease? Because as we go from left to right in a period, we have the same number of shells. So all of them, for example, have 2 shells or 3 shells. But there is an increase in the number of protons in the nucleus. Now, the number of protons in the nucleus, as they increase, that means there is more attraction between the 2 shells and the nucleus, so the atom becomes smaller. So there is a decrease in the atomic radius. Here he's saying the melting temperatures of sodium, sodium chloride, and chlorine are given in the table. Complete the table to show the type of structure, type of bond, force broken on melting, and the particles involved. So, if we're talking about sodium, the type of structure is giant. What about sodium chloride? Well, sodium chloride you should know is ionic, and ionic compounds are also giant. Now, the type of bond broken on melting, well, sodium has what we call metallic bond. The bond in sodium chloride is an ionic bond. Now, the bond in the chlorine is intermolecular force. Remember, he's not talking about the bond inside the chlorine molecule. He's talking about the bond or force that is broken on melting. So, to separate the chlorine atoms, to melt them, we need to break the intermolecular forces or the weak forces between the molecules. These are also referred to as van der Waals forces. Now, which particles are involved? What particles do we have in a metal like sodium? Well, we have positive ions and negative electrons. What kind of particles do we have in an ionic compound like sodium chloride? It's positive and negative ions. Okay, here he's saying draw a dot and cross diagram of PCl4 plus. Remember, when we have a plus, that means the central atom is missing one of its electrons. So that means in this case, the phosphorus, if you look at the periodic table, it should have 5 electrons in its outermost shell, but actually because there is a positive, it has only 4, and it is sharing them with the 4 chlorine atoms. Again, do not forget to write the outermost electrons in the chlorine. What would be the shape of this kind of molecule? Well, look at it. It has 4 bonding pairs of electrons, no lone pair electrons on the central atom, so that should be tetrahedral. So we have 4 bonding pairs of electrons arranged for minimum repulsion between them. Okay? He says an alkene has a molecular mass of 112. What do you think is the molecular formula? Well, you should know that an alkene is CnH2n. So he's saying that the CnH2n should have a total molecular mass of 112. That means 12 times n plus 1 times 2n, that should be 112. And you should be able to calculate that in this case, the n has to be 8. So this is C8H16. Of course, to be sure that that's your answer, just calculate the molecular mass of C8H16. It will come out to be 112. There are a number of different alkenes with the molecular formula C4H8. Draw the structure of the branched chain alkene. So I want an alkene with 4 carbons and a branch chain. So you cannot have them all after each other. So this would be an alkene in which you have 3 carbons and then one of them is a branch in the middle. So this would be the structure. Then he says, give the structure and names of 2 geometric isomers. Again, if he says geometric isomers, you should remember that he's talking about cis and trans, or E and Z. So he wants the geometric isomers of C4H8. That means he wants the geometric isomers of butene. Well, you should realize that you have butene means I have this kind of structure in which either the two H's and the two CH3s are opposite to each other. So in that case, this is a trans butene, or the two methyls are on the same side of the double bond and the two hydrogens are on the same side of the double bond. So that is a cis butene. So these are the two geometric isomers. Here he says 2 reactions of 1-methyl cyclohexene are shown. Draw the skeletal formula of compound X. Now, looking at compound X, it is that hexene, 1-methyl cyclohexene, and I'm going to react it with bromine. Remember that anything with a double bond, you react it with bromine. The double bond opens up, and you put a Br and Br on the 2 carbons that had the double bond. So that's my product. Give the reagent and conditions needed for reaction 2. Well, let's take a look at what is reaction 2. Reaction 2 is one in which he opened the double bond and he put an OH. That's basically hydration of the double bond. That means I need steam and phosphoric acid as a catalyst. Iodine monochloride, okay, this is the second mechanism that you have to memorize. So the 2 mechanisms that you have were either the free radical mechanism, which we discussed previously with the initiation step and propagation step and termination step and so on for the substitution of alkanes with halogens. This is the other mechanism that you're supposed to learn. That is the mechanism of electrophilic addition of alkenes. So he's reacting the alkene here with ICl. So the first thing we need to do is we put dipoles on the ICl. So which one gets the positive, the slightly positive, and which one gets the slightly negative, where the one that is more electronegative is slightly negative. So comparing iodine and chlorine, chlorine is more electronegative, so that's why he put the slightly negative on the chlorine and the slightly positive on the iodine. Now, what's the first step in this? The electrons from the double bond attack the I plus, the I with a slight positive charge, and the electrons between the I and Cl will go to the Cl. So the first step is I get the I. Now, where am I going to put the I and where am I going to put the positive carbocation? Remember that a secondary carbocation is more stable than a primary carbocation. So I put the iodine on the end with the CH2, and the carbon that's in the middle, that's a secondary carbon, that is the one that will be positively charged or a secondary carbocation. Now I have the Cl minus will then attack the carbocation and it will form I on one carbon and Cl on the other. Please remember how to do these mechanisms and with the curly arrows, and each step is very important. Okay, now a question here says a section of a polymer showing 2 repeat units, give the name of the monomer. Now, if I have repeat units, the first thing I need to decide is which part is being repeated. So this part is being repeated. So I need to remove the bond on the right, the bond on the left, and put a double bond in the middle. Now, what is the name of that? That is something that has 1, 2, 3, 4, 5. So it has 5 carbons, and the double bond will be on 2 pentene. Okay. Now, this question says he has 0.01 mole of an alkene. It reacts with 600 centimeter cubed of hydrogen gas with a certain temperature and a certain pressure. Now, use the ideal gas equation to deduce the number of double bonds. In order to get the number of double bonds, what basically I'm trying to get is the number of moles of hydrogen. Now, since I have a specific temperature and a specific pressure, then I have to use the ideal gas law. So the number of moles is now PV over RT. Pressure is 1.24 times 10 to the 5. Volume has to be in meter cubed. So if he gives it to me in centimeter cubed, I multiply by 10 to the minus 6. Now over R is 8.31, temperature is 298, so this gives me 0.03 moles. Now, he says he had 0.01 mole of alkene. That means 0.01 mole of alkene needed 0.03 mole of hydrogen. Simplifying this, that means 1 mole needs 3, and that means I have 3 double bonds. Remember, each double bond needs 1 mole of hydrogen. Okay, this question says, complete the table to show the numbers of subatomic particles in the species. Iron, I have to go to the periodic table to determine the number of protons. Number of protons of iron is 26. That's the atomic number of iron. Now, to get the number of neutrons, it will be the 56 minus 26, that's 30. How do I get the number of electrons? They're supposed to be the same as number of protons, but then he has 2 plus. That means the 26 electrons, we lost 2 of them, and that means I have 24 electrons. He gives me all the isotopes with their abundance. Again, to calculate the atomic mass, it is the mass of each one times its abundance. 54 times 5.84 plus the mass times its abundance, and so on, divided by 100. Now, this gives me 55.911, but he says give your answer to 3 significant figures. Please do not forget to look at that. So 3 significant figures, that means I have to tell him that my answer is actually 55.9. Okay. Magnesium reacts with iron 2 sulfate in a displacement reaction. Write the ionic equation. How do we write the ionic equation for anything? We write the normal equation just as it is. If it needs balancing, I'll balance it. And then he needs anyway the state symbols. Now, looking at the equation, you remember that you ionize only whatever is aqueous. Anything that's solid, liquid, or gas will not be ionized. So that means magnesium remains the same. Now, the iron sulfate is aqueous, so that breaks up into iron 2 plus and SO4 2 minus. Magnesium sulfate is aqueous, so magnesium 2 plus and sulfate 2 minus, plus the iron, which is a solid. And then you cancel whatever the same on both sides of the arrow. And that leaves us with this. So this is my net ionic equation for this reaction. Okay. Again, he says 25 grams of a compound contains 6.98 grams of iron and 6.03 grams of sulfur. The remaining is oxygen. Some of you forget that there is still oxygen that we need to take into account. Now, here, how do I get the remaining oxygen? It is the 25 minus the other one. So it's 25 minus the 6.98 plus 6.03. So that gives me iron 6.98, sulfur 6.03. The rest of the 25 is oxygen, so that's 11.99. Again, the first thing we do is divide by the atomic mass of each one. So that gives us these numbers. And then the next step is divide by the smallest. Now, this gives me 1 to 1.5 to 6. Again, 1.5, I don't round it up. Anything 0.5, I can multiply by 2. This gives me whole numbers. Again, I don't stop here. He's asking for the empirical formula. I haven't finished. Usually, students reach this point and then just move on to the next question. You haven't given him what is the empirical formula. This is the empirical formula. Fe2S3O12. Okay? Now, this is the last question. When 6.95 grams of this compound is heated, 2 grams of iron 3 oxide, 0.8 grams of sulfur dioxide, 1 gram sulfur trioxide, and the other product is water. And he's saying deduce the equation. Well, to deduce the equation, remember that the equation is really a comparison of the number of moles of each one. So I need to get the number of moles of each of these. So number of moles of iron 3 oxide is mass over molecular mass. So that comes out to this number. Now, number of moles of sulfur dioxide, again, mass over molecular mass. Number of moles of sulfur trioxide, again. Now, I have the number of moles of each of these. I should be able to get the mass of water. Remember that the mass of the water is the difference between the 6.95 and the total of all the others. So I have 3.15 grams of water. That means I can get the number of moles of water. And it seems that the number of moles of water is actually 14 times the number of moles of the others. And that means if I want to write a balanced equation of this, I have after the arrow, 1 mole of Fe2O3, 1 mole of SO2, 1 mole of SO3, 14 moles of water, because the number of moles of water is 14 times the others. And then to balance on the other side before the arrow, I have 2 iron after the arrow, so I need 2 FeSO4 anyway. Now we have a total of 14 water after the arrow. That means I need 2 times 7. That means my X is 7. Okay, I hope this was useful and I hope that this will help you in your upcoming exam. Thank you for